Okay, so in this video, I just want to go over the solutions for Exam 3 since we lost some time this week. I was out sick. Um, Before I get into the actual solutions, just so you know where the grades were. For this exam, probably more so than the rest, we did see a lot of people struggle. So the average was in the low 70 range, and that was after a small curve was applied. The way the curve worked, when you get your test sheets back, you'll notice that the amount of points that were added to your total score will be somewhat variable depending on what your overall raw score was. So the people who ended up sort of doing poorly got a little bit more of a boost than those that were towards the top. I'm happy to explain it a little bit more if you want, but the curve was designed to make sure that the people who really didn't do very well got a little bit more of a boost. But you can figure out where you are in this graph and get an idea of where you stand across the class. Clearly, we've got some students that are doing very, very well. And if you're in that group, congratulations, you're doing a great job. And we're probably moved into a part of the semester that is probably the most challenging. Loops in general are where a lot of students begin to struggle. So if you found that this exam, more than any other exam, was extremely difficult, that's to be expected. Unfortunately, the bad news with that is that the next exam will be along the same trend. So we've really moved out of the material that is generally where people do very well in, and we've moved into the material where people do start to struggle. And so you're going to have to spend probably a little bit more time working through your programs. Try to remember the tools that I'm giving you in terms of trying to do your problem solving. Once we now cover loops, we're through loops, and especially that we start dealing with functions. The idea that you're not going to plan out your solution and you're going to kind of just program without a plan. It might have worked up through exam number 2. It won't work anymore. So everything that I've been talking about in the videos, everything that I talk about in class is aimed at helping you think through the problems rather than just typing a lot of code and hoping it works. It's really important that you pay attention to that kind of stuff now because it is getting quite a bit harder. All right, so let me switch over to the exam. I'm going to do the first program first, and then we'll move into the written part. For this problem, it's very similar to a number of different examples that I went over in the module videos and also in lecture. I'm computing a series of terms. I'm asking the user for a number, and I'm computing a series of terms based on x, and I'm accumulating. So if we look at this, we've got x minus 1 minus a half x minus 1 squared plus a third x minus 1 cubed, and it sort of keeps going on and on. And you always want to be able to establish a pattern somehow, figure out what the pattern is. And in each one of these terms, we have a coefficient. Right? So we see the 1 over 2, we see the 1 over 3, the 1 over 4. Fitting together the rest of that pattern, there's a 1 over 1 here that can be placed there with ease. So we see that in the coefficient, there's an increasing denominator. That denominator, so 2 and 3 and 4, also appears in the exponent of the term as well. So there's really just one number per term that is changing or increasing. There's also a multiplier. So if we're going to be doing accumulation, we're probably going to want to add these things together. But notice that we've got a positive term and then a negative term, and the positive term and negative term. This is very similar to that pi example that we did in the module videos. So there's actually two things that are changing each turn around this loop, each time we go around the loop to generate these terms. And it's the sign toggling from positive to negative and it's this denominator or exponent, or maybe we'll call it a factor, that is increasing by 1. So the gist of the program is to ask the user for a number x, and you're going to compute the natural log, or the ln of x. We know that this can be any real number, so we should have allowed the user to type in a floating point value. I didn't see anybody miss that part, but most people didn't assume that these were integers. We also wanted to ask the user for a value n, which corresponded to the number of terms. So, if they typed in just one term, your answer wouldn't be anywhere close to what the log n. If the user said, I want to know the log of 1.2, for instance, it's not going to be anywhere close to the true number. It's just going to be 0.2, right? Because with one iteration, it's just 1.2 minus 1. So it did take a number of iterations for you to start to approximate. And I gave you an example down here where if the user types in 1.2 with 10 terms, you should end up getting a result of 0.1823. Now, I added a few other caveats into this program. First off, and this was probably the most critical, the formula that I gave you is only valid for values between 0 and 2. So I was looking for some input validation to make sure that happened. That was sort of the last thing that you needed to do, and it wasn't the most important, and it wasn't where you got most of your points. Most of your points came from the formula. So let's switch over to the code. I'm going to write my C++. And I know that I have to get x from the user, and I know I need to get n from the user. And I'll put my prompt, please enter x between 0 and 2. Again, I won't really worry about input validation just yet, but we always want to make our prompts as accurate as possible and as specific as possible. Please enter number of terms. It should be a positive number. Maybe we can put that in. All right, so we've got our value. So the first thing that we want to do when we're up against these type of problems, and again, this is something that I talked about in the beginning of the video. Make sure that you proceed through this stuff in a very methodical, step-by-step process. So before I start worrying about x minus 1 and my factors, my negative, I want to make sure that I can just write a loop that goes around the right number of times. So if the user types in 10 for the number of terms, I know that I need 10 terms. So that's the first thing. And it's a really simple step, but it gets you going in the right direction, and it gets you focused on the right things. So how do I write a loop that goes around n times to generate n terms? It's just my standard for loop, and I can do anything I want here. So let's build it. I'll type in 1.1 and 10, and right now I just see that the value term, or the word term appears 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Okay, so I have the right number of terms. At that point, if you're following the procedure that I'm recommending, I'm not going to touch that for loop. Now, going back to the problem description, we had a series of repeating things. We had the sign. It goes from positive to negative, and it flips back and forth. So we can do that first. Right? I'm going to create sign, and it starts positive. I'm going to print this out. And each time around the loop, I want to flip the sign so I can multiply it by -1. Right? So I see signs starting positive, negative, positive, negative. So just one small little step, and I've got those signs coming out. So positive, negative, positive, negative. Now I have the factors, right? So I've got a 1 over 1 here, which and I can raise this to the 1 power, and it doesn't change anything. So that was kind of a decoy there. The first term looks like a special case, but it's really not. The factor is just 1. It's 1 over 1 raised to the 1 power. It's 1 over 2 raised to the 2nd power, 1 over 3 raised to the 3rd power. So let's get factor, and it starts at 1 and it proceeds over. And I'll give some room between these. We know that each time around the loop, factor is going to be incremented by 1. So notice I'm printing it out. I'm using these values in their initial state the first time around the loop, and then I'm adjusting them each time. Avoid, you don't need, if you're looking at this and saying, well, why don't you use I instead, or use I plus 1 instead? And if that's what you did on the exam and you got it to work, that's perfectly fine. But I'm trying to teach you that you want to decouple, or you can at least decouple the mechanism that creates the loop, the number of times you go around, and what you actually do within the loop. Right? They're two separate ideas, and they don't need to be tied together. And often it's easier to decouple them, or at least your first draft of your program, it's easier to decouple them. So now we see the 1, 1, negative 1, 2, 1, 3. If we look at that compared to the pattern we're seeing showing up, right, 1 over 1, positive, negative with the 2, positive with a 3, negative with a 4, we have the exact terms that we need. Now that we got that, it's really easy from here, right? It's just a standard accumulation of a specific term. So I'm going to create my answer value. Accumulation, when we're using addition, should really start with a value starting at 0. And I'm going to create a term, and I'm going to just make it local to my for loop. My term is what? It's the sign times 1 over the factor times x minus 1 raised to the factor. So it's the sign times, or divided by, the factor times power. And as soon as I use that power, I got to think in my head CMath. I need that. X minus 1 raised to the factor power. POW, a number of people left the CMath include out. Please, again, remember you don't want to do that. Visual Studio, it'll compile without it, but on other systems it does not. And I'm really going to be interested in testing your system on those. Okay, so I got my term, and I'm going to add my term, accumulate it into answer. And at this point, I can say the ln of x is equal to answer. And I could probably take out this term for now. I'll leave it in as comments. It might be nice to add it back if maybe the number doesn't show up right. Now the question is, well, how do we know if the number shows up right? Well, then that's where you got the test case for. So 1.2 with 10 terms I've already computed as being 0.1823. So I'll rerun this again. I'm going to type in 1.2, my 10, and I get the right answer. And I didn't really specifically look for input formatting here. You could have done that. Some people did that. That's great. I can leave it like that. Once you get that value, now you start looking at input validation, right? So n should be positive, x should be between 0 and 2. Input validation, really, you want to practice this so you really don't feel like it's challenging at all. It really shouldn't be. While x is invalid, right? It's a do-while loop around the prompt for x. Now, when is x invalid? I saw a lot of x is less than 0 and x is greater than 2. And that's a really a common mistake, but if you say it, if you really think critically about it, it really doesn't make a lot of sense. This statement actually could never be true. No matter what the user types in, there's no possible way that x, the value the user types in, is less than 0, and at the same time it's also greater than 2. That doesn't, it's an impossibility. And the reason we make that mistake a lot is that we use and when we kind of say it out loud and we say it quickly. We just say, well, we're looking for a number between 0 and 2. And the between part is what kind of messes this up, because that's not really what we are saying here. We're saying, well, x is invalid. X is invalid. It is not a synonym, right? It doesn't mean the same as x is between 0 and 2. A statement that says x is invalid is if x is less than 0 or x is greater than 2, and then it's invalid. Right? And so that's what you need there. For the number of terms, if you want to put a do-while loop around that, that's just for positive numbers. So while n is less than 0, or maybe even less than 1, we want a positive number. At that point, that's the full solution. Right? That will give us the input validation we need. If I run this, if I type in -1, if I type in 10, doesn't matter. If I type in a -5 for the terms, it doesn't make a difference. If I type in 100, all right, there we go. And for more terms, I'm not really getting a different number. For the 1.2, that's kind of to be expected. After 10 terms, the number's starting to stabilize. All right, so that's the solution for the written part. So let's now go over to the actual written part, and we'll go over these answers. For number 3, there was actually 2 choices here, A and C, that were pre-tests. I didn't actually write in the question, circle all that are pre-test loops. So I didn't mark off points if you didn't circle them all. If you circled any one of the while or the for loop, I give you credit. If you said all, that was wrong. Do while is wrong. Those are do while is a post-test loop. For number 4, which are the following loop structures best for input validation? Again, that's do while. That's a post test. Most people did very well with that, and I was happy to see that. Number 5 was gave a lot of people some trouble, and it's kind of, I don't want to say concerning, but it's something that if it did give you trouble, you really need to pay more attention to what it is that I'm kind of highlighting in the modules and the courses, because I said a number of times beforehand that you want to be able to write a loop that goes around any number of times, whether it's n, whether it's 10, whether it's 4 plus 2 times. If you have an expression that indicates how many times you should go around a loop, the mechanism for doing that should be automatic. You literally can simply memorize it, or you can write it in your notes, and you can say, look, this limit is going to control how many times this loop goes around. So first of all, choosing the most appropriate loop. If you chose a while loop or a for or do while loop, it really isn't the most appropriate loop for the situation. So even if you got it right, I'm going to give you full credit. But the correct approach is just a for loop, right? And it's a standard for loop. Right? Int I equals 0, I less than whatever the number of loops or the number of iterations you want to go through. Right? So in this case, I want to go around a loop x times 5 times. So x times 5 is what goes right here, I plus plus. Right? I didn't need to see anything in here. If you got this one wrong and you just wrote 5, for instance, or you just wrote x and that was just a mistake, you kind of slipped your mind, you didn't read this correctly, okay. But if you struggled with this one, you need to spend a lot of time thinking about for loops. We are going to be using for loops all the time throughout the rest of the semester. It's going to be one of the most common constructs that you see in your programs, so you cannot afford to be confused with it. Number 6 was hard. I gave you a relatively complicated stop condition. So write a loop that asks the user to enter an integer until they enter a number divisible by either 3 or 4, but not 5. So what is a good number, right? A good number, the number that the user is looking for, it's either divisible by 3 or 4. Right? So we could write that as, x divided by 3, or mod 3 is equal to 0, or x mod 4 is equal to 0. If either one of these conditions are true, that's part of it, right? That's one of the criteria. So how could I write that to mean that this criteria is not actually met, that the number is not divisible by either 3 or 4? Well, it's not just as simple as x not equal 0, x mod 3 not equal 0, and x not mod 4. Both of these have to be false for this to be lining up with what the statement is. So there's the and that's what I ended up with down here. Right? So if we want to think about it, it's like the first part, right? A number divisible by 3 or 4. That's really lining up with this statement over here. But the logic is flipped because we see the word until over here, right? This is indicating that this is a good criteria. This is the criteria we're looking for. So we're trying to keep going around while that criteria is not met, right? So this one's tricky. We're also saying, but not 4, meaning it also should not be divisible by 5. It should be divisible by 3 or 4, but it should not be divisible by 5. So that implies that if a value is divisible by 5, no matter what, in all circumstances, it should be invalid if it's divisible by 5. And so I've got an or statement here with a statement that says, if x is divisible by 5, this would be true. Right? Remember the or condition. If either side is true, it's always true. So no matter what happens over here, if this part is true, the whole while loop will be true, meaning we'll keep asking the user for another number. And you should probably have a better prompt here, but I didn't worry about that when I was grading it. You're writing it by hand. It's a lot to write down. So there was a couple of different ways to do this. I did look at how close you were. You got some most people got a lot of partial credit here. There was a couple of different ways. You might have seen me, if you had something like this, if you kind of wrote it using the good conditions, right, or the positive criteria, something like this. A lot of people wrote this. That was almost there, but maybe one way you could fix this is to circle the whole thing and put a not. Meaning that this expression basically is saying x is good, x meets the criteria, and you want to keep going around while it does not meet the criteria. Either way is fine. I think it was easier for me to write the exclamation mark on your exam, so that might be what you saw. But this is really the best solution. It's the most clear solution. For number 7 and 8, I gave a lot less partial credit. Particularly if you were unable to construct a while loop or for loop. So they both really are two sides of the same coin. Construct a single while loop to print out the following lines. And I gave you a series of numbers. I'm sort of begging you here to use the methods that I talked about in class. I'm asking you to print out a pattern of numbers. The first thing that you should think about is how many rows are there? How many rows am I printing out? I'm printing out 5 rows, right? So I'm going to write a loop that goes around 5 times. Now, if I have to do it with a while loop, I'll use an in I. I'll keep going around while I is less than 5, and I'll do an I++. So that loop structure is standard, right? If I want to go around 5 times, there's my loop. I'm also creating, again, I'm decoupling, right? I'm creating some variables, x, y, and z, x meaning this column, y meaning this column, the middle column, and z meaning the rightmost column. They've all started 4. I'm going to print out 4 in each one of them. And then in addition to incrementing I, so I only go around 5 times, I'm going to change x and y and z such that the next round works. right? So each time around, x is doubling. Each time around, y is getting cut in half. Each time, and by the way, I probably should have had double here. I didn't really take off points if you put int. Again, when you're writing the program, it's hard to debug data types and catch that, but really that should be a double because y is turning into a double over there. And we've got z being incremented by 3 down here. So again, it's so important that you recognize that this problem can be turned into a relatively easy problem to solve by decoupling the number of times you go around a loop with what you do inside the loop, right? Here's how I'm figuring out how many times I go around the loop. Here's how I'm figuring out what I'm doing within the loop, right? And if I saw people doing while, x is less than 64 or something like that, that works. And if you made it work, okay, but you might have been making it more complicated than it needed to be. Over here, right, for loop, and again, this is, I was trying to kind of paint this picture where these are equivalent loops, right? A for loop, you didn't have to change anything about what you did, right? The for loop is just a different way of saying, I want to do this and this 5 times. The for loop just takes the counter, the test, the initialization, the test, and the update, just as we see them in the while loop, and we put it inside of a for loop. But I do the exact same thing as I do in a while loop over here. All right, so that's the complete solutions for the exam. Again, if you have any questions about what I wrote in your exam paper, I'm going to turn the exam back in a few days in our next class, and you'll get a chance to see what I had written down there. If you want to try to stop by during some office hours on Monday, that's fine too. And I will see you next week.